Hello, AFDA students. We are going to do a warm-up to review transformations of functions, and we're going to be transforming quadratic and exponential functions. So right here, I have your parent functions for quadratic and for exponential. And those are very important because we're going to keep coming back to these parent functions. Your quadratic parent function is y equals x squared, and your exponential parent function, it could have a different base from 2, but the one we're going to work with today is y equals 2 to the x. So notice that the difference is that the exponential function has an x in the exponent. So here are two examples of horizontal shift of parent functions. The first one, you can tell it's quadratic because it has an x in the base, not in the exponent. And because the plus 2 happens within the parentheses here, then it's going to be shifting left and right. And remember, the left-right shifts are always opposite of what you think they're going to be. So this function is actually shifting to the left 2. So if you take this here, your point that was at 0, 0, and you shift it left 2, you're going to have a point that's on your new parabola. And you take all 5 points, each point gets shifted left 2, and it makes a point on your new parabola. So this is how we get this parabola here. The second example is also a horizontal shift, but this is a shift of the exponential parent. And I know that because the x is in the exponent. So an x minus 3 is going to shift my graph right 3. This here is your asymptote. Your asymptote is this invisible line that your function will not cross. So your asymptote is at y equals 0. And if I shift it right 3, it's really still in the same place. So my asymptote stays. And then I have these 3 key points right here that I'm going to shift. So I'm going to shift each of these points right 3. So this point shifts right 3, this point shifts right 3, and this point shifts right 3. And then you sketch in your new graph. So I want you to take a minute now and think to yourself, do these look like these are quadratic or exponential? Is the x in the base or is the x in the exponent? And then once you know what shape it is, what transformations are happening to it? So pause the video until you figure that out. All right, you should have noticed that both of these are quadratic, so you're going to be looking for U shapes for both of them. And the transformations, they are inside the parentheses, so they're left-right transformations. Remember that a minus is going to shift you right, so this will shift right 1 from the parent function, and this will shift left 4. Okay? They are both the quadratic parent function, so looking back at your quadratic parent function, I want to shift this right 1. So each point shifts right 1. So this point goes here, this point goes here, and this point goes here. And I took those points from my parent function, and then it's symmetric. So you're going to get symmetric points on the other side. And then you've got your graph. All right, this one shifts left 4. So the easiest thing to move is your vertex, because your vertex was at 0, 0, and it's going to shift left 4. And then you had a point at 1, 1, that's going to shift left 4. And you had a point at 2, 4, and that's going to shift left 4. All right, and it's symmetric, so you've got other points on this side as well. Okay, so if you need to pause the video to give yourself time to graph that, go ahead and do that. Okay, so we're going to turn the page. And these are transformations of the same parent functions from the first page. So you might need to flip back and say, okay, what did my quadratic parent function look like? This was it. And now this function has shifted up 2 from the parent function. What did my exponential parent function look like? That's here. And then this function shifted down 3 from the parent function. All right, so what I need to know now is I need to know which parent function am I looking at and how did it shift. So I can see the x's in the base, so I know that this is quadratic. I can see the x's in the exponent, so I know this is exponential. A minus 5 should shift down 5 from the parent function. Okay, and this morning I saw one of my students use this technique where what he did was he copied the points from the parent function so he didn't have to keep flipping. So he went back to the front and he copied these points here so he would know where they were before he transformed them. Okay, and then he transformed them. So they went down 5. So we're here. This goes down 5, and this goes down 5. This one also goes down 5, and this one shifts down 5. And you want to sketch in the shape, and then you can get rid of your parent function points. But I think that that was helpful. So you don't have to keep flipping back and forth. Okay, we can do the same thing for this one. For this one, I need to know what the parent function looks like for 2 to the x. And so going here, I need my asymptote at y equals 0, and I need my points at 0, 1, 1, 2, and 2, 4. Okay, so I'm just going to do that lightly because I know I'm going to be changing it. 0, 1, 1, 2, and 2, 4. Okay, so everything moves up 4, so that means my asymptote goes up to 4. This point moves up 4. This point moves up 4, and I think I'm running out of space for this point, so I'm just not going to do that point. I'm going to erase my parent function, and I'm going to finish graphing. Okay, and we said that this was a transformation that shifted up 4 from the parent function. Okay, so if you need to pause the video to finish that, you can go ahead and do that. And these are some examples of stretching and reflecting. So you can see that the 3 here was a vertical stretch of your parent function, and the negative here is a reflection of your parent function. So let's turn the page and see what we have. All right, this time we are reflecting the quadratic function, y equals negative x squared. So we said that this is a vertical reflection. And I know it's quadratic because the x is in the base, not in the exponent. So I'm going to do a vertical reflection of my parent function. And I'm going to use the same technique that I used before. I'm going to go back to the points on the parent function, and then I'm going to copy those so I can reflect them. So I've got my points, same points from the parent function. Okay, and then you want to reflect those vertically. So the 0, 0 will stay there, and then this one will reflect, this one will reflect, and here as well, reflect vertically. Okay, so now you have your parabola, you sketch it in, and then you can get rid of the points from the parent function. All right, in the next case, you're trying to decide first if it's quadratic or exponential. And since you notice that the x is in the exponent, it is exponential. So your parent function is your exponential function. And this time there is not a negative reflecting it. There is a 2 creating a vertical stretch. So I'm going to go back to the parent function and sketch that in so I can see what it is that I'm transforming. The parent function has an asymptote at y equals 0, a point at 0, 1, 1, 2, and 2, 4. Okay, so if I stretch by 2, I'm going to be multiplying my y values by 2. This asymptote at y equals 0 When you multiply that by 2, it still stays at y equals 0, but the points are all going to move. So the y value here of 1, multiply that by 2. The y value here of 2, you want to multiply that by 2. And the y value here of 4, you want to multiply that by 2. And you'll see that it does create a vertical stretch of your exponential equation. And I'll erase the parent function points, but it has the same asymptote, so I can keep my asymptote. All right, and then there are 2 challenge problems. These are challenge problems because each one has more than one transformation. So looking at the first one, the x is in the base, which makes it quadratic. There are 2 transformations. You can see one comes from the 3 and one comes from the 2. If you look back in your notes, inside the parentheses, a plus 3 would shift left 3. And then a times 2 would be a vertical stretch of 2, like here. Okay, so I'm going to take the points from the parent function. Remember, go back to the first page. Here's your parent function. And I'm going to plot those points. All right, and then each point goes left 3 and vertical stretch of 2. So go left 3. My y value is 0, and 2 times 0 is still 0. Go left 3. My y value is 1, and 1 times 2 is still 2. Okay, go left 3. Y value is 1, and 1 times 2 is 2. Go left 3, and my y value is 4. 4 times 2 gives me 8. And then this one as well. I'm going to go left 3, and then multiply by 2. And so what you get is a parabola that is shifted left 3 and stretched by 2. Okay, one more. This one we can tell is exponential because the x is in the exponent. The plus 1 should shift it left 1. And the minus 3 should shift down 3. You can find the points from the parent function on your first page here. Okay, and so here's my asymptote and the points on the parent function. All right, so I'm going to do the shift down 3 first because that moves my entire asymptote down 3. And then I'm going to take my points, I'm going to shift down 3 and left 1. Down 3, left 1, and down 3 and left 1. And then you want to sketch in the shape of the exponential function. And then erase everything from the parent function.